Hi, I'm Dane Campbell, and this is my YouTube video for my Sulfur Battery project. With the push for green energy at an all-time high, the need for reliable batteries is drastically increasing as well. The problem with this is that the prices needed for the materials needed to produce these batteries is also increasing due to pushed efforts to conserve natural wildlife areas where these materials are common. These materials include copper, zinc, lithium, lead, nickel, and many more. With these batteries becoming more and more expensive for the average consumer, something clearly needs to change. This is where sulfur batteries come into play. The idea for sulfur batteries has been around for quite some time and was first patented in 1962 by chemists Herbert Danuta and Ulam Julius, but didn't gain any real traction until the early 2000s when the need for new batteries became more and more prevalent. The idea is very similar to any other battery on the market. Sulfur would be used as the cathode and lithium would be used as the anode. They will be separated by an electrolyte on both sides, and in the middle will be a semi-permeable salt bridge. When the battery is on, then the lithium ions travel to a cathode while the free electrons power whatever needs to be powered. What we benefit from these batteries is first, sulfur is far less expensive than commonly used metals used in building other batteries. Sulfur is the fifth most abundant element on Earth. Furthermore, the same batteries can be made by replacing lithium with aluminum. This idea is very new and was proposed by a professor from MIT named Donald Sadoway in 2022. Unlike mining for metals like nickel and cobalt, which are not only harder to find, but also cause health risks like contaminating water, sulfur is so abundant that it's almost limitless. It does not pose any health risks and is a byproduct of the refining of crude oil and natural gases, so it can be used to clean the earth as well. With aluminum being the most abundant metal on Earth's crust, the cost of these batteries will decrease even more so. The largest difference between lithium-ion batteries and lithium-sulfur batteries is that while lithium-sulfur batteries use sulfur as the cathode and lithium as the anode, traditional lithium-ion batteries used lithium as the cathode. Another added benefit of replacing lithium-ion batteries with aluminum-sulfur batteries is safety. With lithium out of the equation, they can be transported much safer by airplane without the fear of reactions with oxygen in the air or aluminum on the airplane. Also, unlike lithium, aluminum isn't flammable, which makes it safer to go in things like cars and power plants. The process used to make sulfur batteries of either kind is very similar to the process used to make lithium-ion batteries. This means that the same factories can be used to produce sulfur batteries. Plus, it will also cost slightly less because it takes less energy to make due to the fact that sulfur crystallizes at only 112 degrees Celsius compared to the thousands of degrees it takes for other commonly used materials to melt. However, the biggest draw to sulfur batteries is how much energy they can store. A sulfur battery compared to a lithium-ion battery can hold 2 to 5 times more energy. This makes them perfect for things like power plants and storing their energy, drones, and ever-increasing and in-demand electric cars. The batteries are so enticing that they are already used in some drones due to how long they can keep the drones in the air without needing a recharge. There is only one real problem with the batteries, however, it is a big one. During the charging of the batteries, sulfur is unable to properly distribute the ions back onto the anode. This causes small, spur-like metal strands coming off the anode known as dendrites. These short circuits happen when a dendrite gets too big and pierces through the separating salt bridge into the cathode side. Due to how densely packed these batteries are, intense heating occurs when the short circuit occurs, which can cause the fires and explosions. These dendrites drastically reduce the lifespan of the batteries. From what could be well over 1,000 recharges on a lithium-ion battery is cut in half to just about a couple hundred recharges in many cases with the sulfur batteries. Although lithium-ion batteries still do form dendrites, lithium does a far better job at redistributing the ions back onto the anode than sulfur does. To fix this, researchers made a porous composite called sulfur-impregnated disordered mesoporous carbon. This compound allows sulfur to still be used by being so porous while not having to worry about it dissolving into the electrolyte used. Another benefit of sulfur batteries is how light they are. Being about 2.5 times lighter than the lightest lithium-ion batteries, it makes them perfect for electric cars, and someday electric aircrafts would need to be lighter to hold more cargo and or passengers. Also, if an electrolyte is flammable, then the dendrite can cause a flammable short circuit, which would be very dangerous to put into cars and other machines. There are measures that are being used to try and stop these problems, like using a non-flammable electrolyte to reduce the risk of fires. This would help with safety, but the lifespan of the battery is still in question. Another idea is to use lasers to force the ions into the correct spots. This would help increase the lifespan of the battery, but the price of the batteries would increase, which was the first problem that arose. Another slight problem with the lithium-sulfur batteries is that although the sulfur batteries might be theoretically safer, extensive tests still need to be done since the technology is still new and haven't been used much. This will cost time and money, and some people may worry if it is worth it, since lithium-ion batteries already have been tested and have distinct boundaries on what they can and can't be used for. The batteries are rapidly getting more and more popular, especially in places like China and Japan, where the government is rapidly trying to become more electric vehicle driven. The lithium-sulfur battery market is currently at $200 billion globally as of 2023. However, it is projected to reach $429 billion by 2028. The leaders for the sulfur battery push are Nextech Batteries Inc., Polyplus Battery Company, LG, Saft Group, and GS Yahusa Corporation. No solution has been perfected yet to use these batteries on a wide scale. They are already used in things like satellites and drones, where they don't need to be recharged often or in some cases at all. But to use these batteries to solve the problem of ever-increasing battery prices, something needs to change to make these batteries reliable for a reasonable amount of time.